So two pointers technique in data structure. What exactly the two pointers technique is? The two pointer technique is a popular approach used in solving algorithmic problems, particularly those are involving array, linked list, and a string. And this this technique, why we call it two pointers? Because it involves two pointers that traverse through the data structure in a way that helps to efficiently find a solution. The basic idea is to maintain the two pointers that moves through the data structures at different speed or in a coordinated manner to achieve a specific goal. Now, what is this is the introductions of the two pointers. So let's understand the basic concept of two pointers technique. Basically, that involves three things: initialization, movement rule, and termination conditions. We're gonna look each of them in detail. Initialization of two pointers at the beginning of an array or list, or you can depend on the problem, right? What is the statement of the problems and how we can fit in. So we will look at the template, how these things get fit in. And then second one is the movement rule. How we're gonna move one or both the pointers based on certain conditions or the criteria. And the third one is the termination conditions. What is the termination condition? Like continue, we have to know exact conditions at what point we have to exit, or like until either one of these point is exhausted or they reached or we find the solution. There are certain conditions we depends on the problem statement. If the criteria for the certain condition is met, we have to exit out. So that's the basic concept. Okay, so as we've seen, the basic concept of two pointers technique is initializations, movement rule, and the terminations. So let's convert these ideas into the instructions. So number one, we're gonna initialize the pointers. So we can call these two pointers either the first or second, or we can call them left or right. So that's two things we can do, the initialization. The second thing is, so first index, you can initialize at 0. Second, you can initialize at the end of the input. That could be input.length -1, or both of them can be initialized at the start of the index. Depends on the problem statement, what we are trying to solve, what solutions we are trying to find. The second thing is we have to use a while loop until the pointers are equal. So we're gonna move the pointers either in the same directions or in the opposite directions based on the problem statement. That is most important thing. Based on the problem statement, we have to apply the while loop, right? Whether we are initialize the pointers, and then based on the problems, we have to construct the conditions for the while loop, how we're gonna move it. Either we're gonna move the opposite direction or we're gonna move in the same directions. So same direction when we move, that means we initialize the pointers at this start of the input, and we're gonna increase both of them. When we are moving in the opposite direction, we're gonna move one by incrementing, second by decrementing, the left and right. And the third is the each iterations of the loop. We have to we have to check the condition whether these two pointers are getting those values which we are looking for or not, right? So let's see. Uh, let's take an example. Let's take an example of a string. So we have given a string and we have to see if this string is a palindrome. Otherwise, we have to return false. So what is palindrome? Palindrome is a string if it reads the same forward and backward. So basically, let's say example, if I have this word race car, okay? If I reverse this, right? Reverse mean if you reverse all the characters, it will still become race car, okay? Now, how are we gonna solve this with the two pointers? So solving these problems with the two pointers to check if it's a valid palindrome or not, we need the two pointers. Two pointers, we say one is left, we're going to initialize here, which is left equal to 0, and the second pointer is at the right side, end of the string, which is 0. Sorry, length minus 1, right? And so this is the number one, the initialization. The second is the movement rule. So we're gonna move these two pointers in the opposite direction until both of these are equal. So we're gonna apply the while left is less than right. We're gonna keep continue and we're gonna check. So what we're gonna check here, this is the condition here, the third one, condition. So condition is every time when we enter into this loop, like the each time of the iteration, we have to check if the character, a string character at left index is equal to the character at right index. Okay, as long as these two are met, are equal, that means the this string is a palindrome, right? So we can set up an exit condition here. So when we say if these two characters at these two pointers, if these strings are, if the character is different, this cannot be a palindrome. Okay, so if we run it, let's look at this. So when we are at the index 0 and the other one we are indexed at length minus 1, we get these two characters are in R, and these two are good, right? They are matching. We can move the left index towards the right. So now we increment the left plus, and we're gonna move the right, like we're gonna decrement the right index to here. So the next character we're gonna check, our loop will check this condition. The next characters at the left and the right is still AA. We're gonna move again and we're gonna continue this loop until both the indexes become equal, right? And that will be the exiting point for us. Okay, that says yes, it is a palindrome. And similarly, if we look at the case for the second string, where we see, okay, if we have a string s equal to a b c d e a, okay, the left index, the left is equal to 0, right equal to length minus 1, and every time in the while loop we're gonna check these two, the values, this is same, right? So the index will move to the next one, and here we see the characters at the index left is not equal to the character at the index R, so we are exiting. All right, so now we are going to see how we're gonna convert those instructions into the code. So what we are doing is we are going to write a method which will check if the given string is a palindrome or not, right? So in this class, I will say public boolean is palindrome. So palindrome, and it will take input as a string. I will call s, and right, so that's my method signature. And how we gonna approach this two pointers technique? That we need rule number one, the initialization. So we have to initialize two pointers, which we have to initialize to integer variable that's gonna hold the two pointers. So I will say first is left, and I will say it's 0. The second I will say right, which is going to be the end length minus 1, as all the index in the array start with 0. So this is my initialization happen. The second is the movement rule. So what we say, while we're going to continue until my left is not equal to my right. So that will continue. And in this one, if I'm going to check if char at index left is not equal to characters at index right. All right. So what I'm doing here is, whenever I see a mismatch at the left and right index, I am going to exit right there. Yeah. Or else I will continue. So what I'm gonna do, if my left and right index are, if my left and right index are, the value at the left and right index are matching, I can proceed. Right, I'm gonna increment my left index and I will decrement my right index. So I'm gonna increment my left index by increment operator, and the second is the right, which I will say this one. This will keep continue, and once we reach to the point where left and rights are equals and matches all the characters at left and right position, then we will exit out the while loop and simply return true. Right? That's it. So this is the term. You see this first two lines are the initialization, and this is my movement rule. And here is my termination condition. Okay, this is the movement rule, this is the termination condition. So we can say this is the initialization, and this is movement rule, and here is the termination condition. Right? Beautiful. So as we see, the first approach where the two pointers were moving in the opposite directions, right? One left pointers we initialize at the start of the input, and the right pointers we initialize at the end of the input array, right? So this approach is useful for searching pairs or elements that satisfy the specific conditions. Another approach we have with these two pointers is the same directions. Okay, so that could be when we have given some, let's say, an array, like two arrays, and we have to merge them together, right? That's where like we need to move those two pointers in the same direction. Or another one is, let's say you have a linked list, and in the linked list you need to find if the linked list has a cycle, if there is a loop in the linked list. So there is approach, and we will look into those problems in details later on. The the most important part of this this things is, right. I think if you understand the basic concept around it, you have to do two things, right? Either the problems which you are getting is gonna solve with the two pointers in the opposite directions, where they moving the pointers in the opposite directions or in the same directions, right? So based on these two things, right, we have think about these two templates. Okay, so the number one is when it comes to the opposite directions. So in that, what you have to do is start one pointer at this first index, let's say 0, and the other point is at the last index. That's the input and length minus 1. And then use a while loop until the pointers are equal to each other's or one of them is exhausted. So this is exactly same template which we have seen in the previous example when we see a string is a palindrome or not, right? The other template we have is using the two pointers in the same directions. So in that, what we have, like we could get more than one input. Let's say the example, we will look into that example. So you have given the two arrays and two sorted arrays, and you have to merge them and create a new array, right? So what happened is, like, how you gonna solve? You're gonna create the two pointers, one for each iterable, like the array one and array two, and each pointer should start at the first index. Okay, and you need see you have given the two sorted arrays, and then you have to create a third array which is gonna be merge of these two, and it's also be sorted. Okay, so based on so in the step one initialization, two pointers initialize to the first index of both the inputs. Then we compare the numbers at that index. And based on whether it's less or greater, we just do the checks and create the and add them into the newly created array, right? So use a while loop until one of these pointers reaches the end of the iterable, and because we are using the two inputs, so it's possible that the one of them is gonna exhaust earlier than the other. So then we may need to write some extra codes, and that extra code will take care of the other pointers, uh, right? And it will make sure that both pointers are exhausted. So these two templates, same direction and the opposite directions. The key points to remember is with this approach, the two pointer approach, the time complexity is often in a linear or linear thematic time complexity, and that makes it efficient for the large data set. Even for the large data set, you will see the time complexities in. And the space complexity, we are only using the two variables to hold the integer, hold the pointers, right? So this is very memory efficient technique. Okay. The other thing is needs to be remember that when we are talking about the last example where we're talking about the sorting of merging the two arrays, right? Remember one point that this two arrays needs to be sorted. Or if you are finding the pointers, finding those 2 points where the sum of those 2 points are equal to the target, you still need to make sure that those two arrays are sorted. That's some key points that you need to remember. These are the few examples which we gonna cover in details, right? Palindrome we have seen. Similarly, the two-sum, three-sum, merge sorted array we were just talking about, moving the pointers into the same directions, and the container with most waters. These are few example. We will try to solve the problems related to these in more details. That will gives you more better idea about the two-pointer techniques, and more practice you will do with this technique, you will get better with it. So yeah, I think that's what we have. Thank you so much.